finished
That's so
I.
hard.
So we got 53.13.
Are the trig identities on this test? Or you make it look like one?
Yes. Yes. Is that a good thing?
No.
No.
I got a 50 on that test.
Not a good thing.
Nope.
So that might be something you want to study.
Yeah.
Okay.
Or get one to look like the other.
Yeah.
Isn't one of those 1 point things that you don't even need to do the rest of the problem?
That was a group. I think it's on the points on the unit circle. We did that. We did a trig unit as a group.
I remember the get this to
I actually focused on it twice because I figured the first time you worked in a group for the
Yes.
yeah.
Oh yeah, what was the second?
Are we going to start?
Say that again?
Are we going to start?
Yeah, I'm taking roll right now. And I think the main goal of us going over the third test is to kind of find an air of confidence. Because a lot of times kids will get into the test, they know how to do a concept, but they don't know how to utilize the concept. So we're trying to go through questions to say, how would you attack it? What are they asking? So that's kind of where we're at today. We're
This is the ACE exam?
This is the ACE exam. They take it on the 3rd. So that's soon. Just to kind of recap, just so you have an idea, typically these tests are going to be an hour and 45 minutes. They know that this test is worth 75 points and that the statistics one is worth 50, again for the total of 125. Last year they needed approximately 43 total points to earn college credit out of 125. So today and yesterday and the day before, what we've been doing is doing the process, talking about the problems and how many points they could accumulate with their confidence level. So we did number 1, and everyone felt really comfortable that they could have pulled 3 points. So what we're up to now on this test is we are up to finishing number 9. Okay, number 9 actually is about geometric and arithmetic progressions. We already did the geometric portion of it. We started working with the arithmetic. Can anybody remind me what I mentioned about that one, this particular question when everybody left there last year? Yeah, do you remember what we talked about?
That there were sines and cosines and they like panicked or something?
There were sines and cosines and they panicked, right? So they said, I see arithmetic, I see the word sine and cosine, I'm out of here, right? So really we can't think that way. We actually have to say, how could this work? How can I make this work for me? I know how to do arithmetic. I know how to work that process. So what am I going to do to be able to get through that? And we got really comfortable with doing it with numbers. Let's get comfortable with doing it with words as well. So we walked through the process yesterday. Did we finish I?
Yeah.
Did everybody get it done? Like, because a lot of people are just watching because Nick Epler is videotaping me, and he actually, so they can go home and do it at home as well. So we finished this. We understand how we got there. A lot of times, remember when we talked about the word sine and cosine being in the problem? If those words, sine and cosine, are all to the same degree, sine to the first, cosine to the first, sine squared, cosine squared, what did I give you as a healthy hint to do? Yeah, do you remember?
Did sine on one side and cosine on the other and then divide it by cosine?
And make it?
Tangent.
Beautiful. So if you see the word sine and cosine to the first, or sine squared, cosine squared, sine cubed, cosine cubed, don't panic. See if you can go into terms of tan. In this case, they kind of led you in that direction. Yes?
That's what you're saying. If you had, like, let's say you had sine and then cosine, you put sine over cosine, and then you can put cosine over everything?
If you put sine over cosine, if you divide everything by cosine, you know that you're going to get the word tangent if the word sine is in there.
Cosine is just 1.
Yeah, and cosine over cosine just becomes 1.
And you're allowed to do that?
Yeah, that's the goal, but the key is make sure they're all sine to the first or cosine to the first, where you end up with the word tangent every time. There was one problem we did this year where there was varying exponential powers, but when you divided by cosine, you actually divided by the highest level of cosine that they had, and it turned out to be all in terms of tangent. If I can go back and look for that one, we'll go through that process and look at it. It cancels everything out. That's what we kind of did. So this problem, although it's arithmetic, is one that we were talking about when we first started. Do we have to do this on this test? And the answer was yes. And this is a great example of that. Okay, Clea, yes.
That method you just does that only apply to this or does that apply all the time?
It applies all the time. Because a lot of times you're going to come up with problems that have trigonometric identities and you have to make one side look like the other, or you have to show one side is the other kind of thing. Remember those? And a lot of times, if you see the word sine to the first and cosine to the first, you should think, can I make it become tangent? Because if I can make it become tangent, I can solve for it pretty easily. Yes, question? Your hand kind of went up, but not.
Me?
Yeah.
So you're saying, so if you had sine over cosine, and they're
Right.
both just sine to the first over cosine, you can divide the top numerator by cosine and the bottom by cosine?
And you get?
And you would get the tangent. Well,
Right.
the sine and cosine comes tangent, and then
Right.
cosine over cosine is just 1, right?
Right.
Yeah.
Exactly right. Good recap. Okay, now, find the sum of the first 20 terms of the progression. Once again, this is talking about an arithmetic progression. Okay, we now know that tangent of x is equal to 4/3. Yay, life is good. Okay, let's go back and remind ourselves. On our bright colored sheet of paper, we actually have the formulas for the arithmetic progression. So I need you to, if you don't have it, that's no big deal, but can you guys remember what the arithmetic progression formulas are? What's one
For
of them?
arithmetic, for the sum, it's s sub n equals 1/2 n times 2a plus n minus 1 times d. Plus n minus 1
I'm so impressed.
What about the n? Is there an n?
times d.
Is there an extra n in there somewhere?
1/2 n.
I
One
just
FM.
dropped it by mistake. He said it.
What are we doing?
No, that, yeah,
No.
I thought he said it.
Did he say it? I dropped it.
Is that an A? What is that?
Okay, so
Oh, 1/2.
Yep.
good news. I actually learned it in the olden days and divided by 2.
It's the same thing.
Right, it's the same thing. But that's back in the Dark Ages, right? So on your bright colored sheet of paper, though, it does say 1/2 n. And then 2a plus n minus 1 times c. The beauty of this is that you don't have to know it by heart. You have a reference sheet. Yay, so that's cool. What is another formula that goes with arithmetic progression? Does anybody remember, other than Nick, who knows it like the back of his...
UN
What is it? UN?
equals A plus N minus 1D.
Notice that this portion is actually incorporated into this. If I took the two A's and separated, had A plus A, N minus 1 times D, you would notice that UN is located right here. Right?
Because it's really first term plus the last
That's
term.
exactly right. So we thought about that when we learned it. It's really first term plus the last term. That's exactly what this is. But a lot of times we don't have the last term. We have to find the last term before we can do what we're doing. So,
We just go back and
yes.
What is you represent?
UN is the words that's what they use. I always said AN back in the Dark Ages, so sometimes we kind of go between the two. UN means the very last term of your sequence.
So it would be like the 20th?
The 20th in this case. So what
Yeah.
would N be in this case? It would be my 20. Exactly. It varies from problem to problem.
Yeah.
So now we have the sum of the first 20 terms of the arithmetic progression. So I know that the formula that we have to use is this one. The beauty of the arithmetic one is that it doesn't have two different formulas like geometric does. Remember with geometric you have the sum of a finite series. You also have the sum of an infinite series.
Yes.
So you have to be aware what's happening with geometric. With arithmetic it's a little different. It's just what we have. So the sum... So, when I first started teaching you this, what we talked about is how do we go about this process of doing these. So, I taught you what the N meant, what the A meant, what the D meant, all that kind of stuff. So, what I want to do right now is kind of look. Remember, my first term is 2 sine of x. My next term was 3 cosine of x. My last term is sine of x plus 2 cosine of x. Once again, last year they looked at it and said they put trigonometric functions with arithmetic progression. I am done with this problem, moving on. But I think now that we have a comfort level, I'm hoping that we can have a feel that it might not be as bad as we think. So let's go through this process and look. Okay, so the sum of the first 20 terms, this is our formula. Let's break it down. What is N in this case? Maddie
20.
told me 20, right? So 20. We're comfortable. Is it always 20? No. Read the directions, right? Read what they're asking. The next thing that we have to know is A. A represents A1. A1 is our first. So in this case, A is 2 sine of x.
And then D is the difference.
What does difference mean once again?
First term minus, second term minus first term.
Right, or
Third term.
Minus second term.
or again and again and right. We
Etc.
can play this game all day. So D is the 2 consecutive terms. I don't care which 2. 2 consecutive terms subtract each other. So
Yeah.
yeah, 3 cosine minus 2 sine,
Yeah.
right? Is that good? No?
No, I get it.
You sure? Okay. All right, so everybody on the same page? Kalia, you're good with this? Good, looking good? Yep, Ian's got it. Jamie, you're not writing, but you're looking, okay? Yeah?
Don't we have to do the U of M first to find 20?
We might. Because we don't
have
know.
to do the first term plus the U of M.
Right.
Wait, I don't understand. Why would you have to find the U of N if it's already in that?
It's in the formula. So, okay, back in the dark ages, remember I had a little one down here where it said n divided by 2 and then a plus u of n?
Yeah.
We would have had to find u of n. The good news about this formula they give you, it's built in. U of n is built in.
So
You don't actually have to go through that process of finding it. Okay?
Are you gonna?
Am I going to want it?
I'm gonna see.
You want to see what I do? Okay, so the sum of 20 terms. That's what we're looking for,
Yes.
right? Okay, so we're just going to start filling in what we know.
20 over 2.
20 over 2. Ian, you're good? You're on it, right? 2 times, what's the first term?
2 sine x.
2 sine x. Was it helpful to go ahead and write them out? I think so.
Yes.
And then plus,
19.
20 minus 1.
right? So can I just put 19?
Yeah.
Yeah. And then D, my common difference.
3 cosine minus 2 sine.
3 cosine minus 2 sine.
No.
Right. So now we got some pretty math work to do. Okay. So let's keep working. So over here, I'm going to move over here because I got a lot working going on there. So let's clean her up a little bit. The sum of 20 terms, I got 10. I got that under control. And then what does this become?
4 sine
4
x.
sine. We're good. So 4 sine. Okay, moving on. We have the 19. The 19 must distribute to both components, right? So 19 times 3. 9 times 3 is
57.
57. So plus 57
Cosine.
cosine. Thank you. I appreciate that. And then minus 38 sine of x. Okay.
And then the
Add like
10.
terms divided by cosine.
So, oh, let's talk about that. So what do we have there? That's ugly, right? We have 57 of cosine of x, right? And then minus 34 of sine of x.
Do we just leave it?
I don't think so. We actually have to find a value.
Would you multiply the 10 into...
Does it tell you?
Yeah, I don't know.
It leaves everything in terms of...
It really doesn't. And then the other day, here's something that I thought was really kind of funny. The other day I said, Nick, draw me a triangle. And he did. And then we giggled a lot. Remember? Does anybody remember that? Okay.
Yeah.
Why did I ask you to do that? Well, let's kind of talk for a minute. Why would they make me do this problem? Go ahead.
Couldn't you FOIL out the 10 and then bring over either sine or cosine, whatever, and then you divide it by...
Well, it's not equal to 0.
Then you have a weird... It's the
Like-
sum of 20 is equal to that.
Yeah, it's not equal to 0.
That's why I use that tangent
Well-
that you got in the last talk.
Let's see. Let's talk. We have some thinking to do here. Tangent. Tell me what we know about where tangent is located, first of all. Tangent is located where what over what?
Sine over cosine.
And in this particular case, tangent is positive. You
Yes.
agree? So where is my tangent going to be positive?
There and there.
It says it's an acute angle, too.
Oh, was that important?
Yeah.
What does acute mean?
Less than 90 degrees.
Smaller
So
than
it's in the
90.
first quadrant.
So it's in the first quadrant. Holy cow. So they're telling me something really important without telling me they're telling me something important, right?
Yes.
So we got a problem going on here. We're going to draw a triangle. Unlike the one that Nick drew for me the other day. touch my phone, sorry. Unlike the one, he drew a really cool one the other day, but it wouldn't have worked for us. Okay, so what do we have here? I know that tangent is 4/3. We did this for a reason. I know that now that your brain is working. When we draw this triangle in the first quadrant, before I move forward, does everybody understand why we chose first quadrant?
Yeah.
Anybody out there going, why? Kalia, can you tell me why? You got me?
Mm-hmm.
Okay, why is it? Just give me it. Because it's less than 9. It's an acute angle, and tangent is positive. Cool? Right? So here we are. What is tangent? I know it's what? Sine over cosine. So it's y over x, also known as opposite over adjacent. You guys with me on that? So my reference angle is always this guy right here, the one that's closest to my origin.
Yes.
So opposite is here.
Yes.
Adjacent is here. So far, so good?
Yes.
So if I'm looking at this, I go opposite is
4.
Adjacent is 3.
Yes.
How do we find the hypotenuse?
A squared, B
A squared, B squared equals
A
C squared.
squared plus B squared. My God, this is ace math. Why are we doing that, right? We have to kind of come back to what our concepts that we know are. So A squared plus B squared equals C squared. 3 squared plus 4 squared. So 9 plus 16 is 25. So it's a 3, 4, 5 right triangle. They were very nice to us. Okay, so it's a 3, 4, 5 right triangle. Before I go any further, from this triangle, now I know I can find sine. What is the value of sine of x?
4/5.
How do you get it? Tell me.
Opposite over hypotenuse.
So 4/5 is the value of sine of x.
Yes.
It's a negative 34 times 4/5.
Yes?
How would you know to start drawing a triangle from that?
I know from here, because
Yeah.
at this point, I don't have any values for x.
Okay.
Does that make sense? I'm kind of at a loss. Unless I think that I'm
So
going
do you still need to show how that work?
You have really done the work here.
Okay.
The assumption is if I know that tangent is a 4/3, I can find the sine and the cosine from it.
Okay.
Yes.
If you got to the point that we're at right
You're going to get a lot of points.
Okay.
And I'm going to bring up the mark scheme. Remind me at the end. We'll look and see how many points you would have got. Yes.
I was going to say, can't you just inverse tan 4/3
X?
and get x and
Yes.
plug x in?
Okay,
Yeah.
so.
Way easier than drawing
Wow,
a
that's
Yeah.
way easier. I think my way is pretty easy too, but you're right. What did he just say? He said, can I inverse tan this?
Mm-hmm.
If you do that, you're going to get your decimal answer. You won't get 4/5 probably. You know what? Do me a favor. Inverse tan and find your x.
Did 53.13.
Okay. And then when you did sine of 53.13, what'd you get?
So sine of 53.13, you get 0.7999, so 0.8.
And what is 4/5 equal to?
0.8.
I'm so excited. Now, remember,
It's not
your
funny, it's
answer
not
might be a little off, but that's okay, right? Was that geeky? I'm sorry.
I think it's.
You guys have 2 different ways to kill to skin whatever. I don't okay. To kill or skin whatever. You know, 2 birds with 1 stone. I don't even want to go there. Yes.
I don't quite get why you didn't solve that equation like you really had.
Okay, so why did I not just start solving? Distribute the 10 through, bring it over,
Because it's
solve.
not 0.
It's not equal to 0.
Oh, right.
If it's equal to 0, I'm good to go. I'm moving on.
So this is good.
So wait, what's cosine?
Okay, so what's cosine? Okay,
3/5.
think of your question while we're doing this. So we
Cosine.
got 3/5.
3/5.
Oh, okay. Yeah.
So exciting.
And then 50, you have to do 57 times 3/5
Right.
minus 34 times 4/5, which is 7.
Right.
Well,
Well, you know cosine of x
which is
now.
0.7 times 10 is 7.
Oh, did you like it? That's cool. All right. So cosine is 3/5. Sine is 4/5. We can just plug those in, right?
Yeah.
You have 0.7.
So 10 times 57 times 3/5 minus 34 times 4/5. Do a little bit of math magic with your calculator.
It's 0.7 in the middle times 10 is 7. I mean, it's
10 times
7,
0.7, you said?
7. Just 7. I lied in my head.
It's just 7.
It's 7.
It's 7.
Yeah.
It's
There you
70.
go.
The answer's 70.
70 at the end.
I lied in my head to myself.
You did it in your head.
No, I wrote it out.
You wrote it out, but you
Yeah,
wanted to put a point there to
But I
make it
got-
more attractive.
No.
Oh.
I don't know what I was thinking.
I'm with you.
I know what I was thinking, but
It didn't come out right.
So, okay, so if we just plug in our little calculator and do it that way, are we going to get 70? Yeah, we're going to probably get like,
Around
69.99999, whatever. Who cares? It's 70.
Actually, it's 70.
No,
You get 70?
It's directly 70.
Beautiful.
There's no decimals.
Beautiful. I'm excited. So what do you think? You guys would have seen that problem and said, out of here.
Don't understand how it's only 3 points.
I know.
That's only 3?
They should make this like
I feel
7.
like that should be the one that was like 7.
Listen
Number
though.
9 was technically 9 points.
That would have been
Yeah.
9 points that I missed.
In the scheme of things, see, because you saw the word sine and cosine. In the scheme of things, 3 points is a lot. It doesn't seem like it. But every single point counts.
In this case,
We minute to win it every second.
Dude, we had to win it.
It was. Okay. Let's move on.
so now we're gonna work with vectors.
Vectors.
I like vectors.
Yeah.
This one I don't like. I don't like vectors.
Lines in space.
You got an A on this test. This is your test then. This is yours
I
yours to conquer. I like the vectors when they show you the three-dimensional and you can walk along the
Yeah,
wire.
that's cool.
I think this is very logical.
Like a picture book.
Okay, relative. It's like a picture book.
See, I'm gonna walk in and be like, oh, this will be fine. And
That
then
doesn't make any sense. But then
look
again,
at
neither
it
do
and be like,
I.
oh, well.
Okay. Relative to the origin, the position vector ABC are given by OA, OB, OC. Find the value of K in the case where angle AOB is 90 degrees.
Dot product is 0.
When dot product equals 0.
Dot product is 0.
You guys are killing this. You guys, no problem. Hopefully 2 points, right? So I need to find angle AOB. So I do
Cosine
the
theta.
dot product of each, right? Yes?
It's gonna be cosine theta is equal to A dot B over length of A times
That
length.
is actually like the full formula. The full formula is cosine theta equals A dot B over length of A, length of B.
Is this
Okay.
A dot B?
I never.
Now, let me tell you something about this. This is the formula they give you. They actually give it to you a little different. The lengths are on the other side. But here's the thought process. For it to be a 90-degree angle, cosine has to be 0, right? So what would cause this whole side to become 0? Just the dot product, the numerator, to be 0, right? So literally, you only have to find dot product is 0 to show where that happens. That's why you don't have to do the whole thing. So I'm going to do 2 times 5. Good.
Now I got a question.
Go ahead.
How did you know that it was the AOB was those ones? Because I remember. Oh wait.
It has
A O.
B.
Okay.
Yeah. You good? Okay. She saw it.
No, she.
She got excited. She got kind of nerdy for a minute. It's okay. It's a safe place to get nerdy. All right.
Equals 0.
So here we are. We have A dot B, and that's going to be equivalent to 0. So my dot product has to be 0. This is a pretty simplistic solve.
K is
So 10
5.
minus 1 minus 2k is 0. 9 minus 2k is 0. 9 is 2k. K is 4.5 or 9 halves.
Yep.
Good? That was easy.
Is that on the reference sheet?
This,
different.
it looks like, this is like back in the Dark Ages version. This is how they give it to you.
I like the Dark Ages version.
Me too, because I like it where you have cosine equals. Then you can solve. That's how they give it to
Cosine
you.
has to equal.
I read it as theta equals inverse cosine of all that.
That's smart.
Yeah, that's
Okay. Then it says, find the possible values of k for which the lengths of AB are equal to the length of OC. The length of. So we need to know the length formula. We also need to know how to find AB. Right now they're giving you OA and OB. You subtract.
B minus A.
You have to do B,
B minus
minus
A.
A. Right? Okay, so let's go. Hey, can I erase this? So, first of all, the length formula looks a little bit about like the, almost like the Pythagorean theorem. Square root. It's got a squared plus b squared plus c squared, all of that square rooted.
Yes.
Okay? So, if I'm looking at this, AB, first thing I need to do is find AB. So, what is AB? Well, how do I do that? I do B minus A.
Yep.
So 5 minus 2, 3, right? Negative 1 minus 1, negative 2. And then K minus negative 2.
K plus 2.
Is it, do you not? Oh, never mind.
Okay. And then it said the length of OC. Well, the length of OC is given, right?
Well, you can find it.
We can, sorry, OC is given.
Yes.
We can find the length. Thanks,
So
Rick.
why
Go ahead.
would you put 9 halves in for K?
This is, okay, so in this case it said find the value of K in the case where this is 90 degrees. It's not always going to be a 90-degree angle. So now they're saying find the possible values, should be 2 answers, which the lengths are equal. So it's a totally different K we're looking for. Okay, so OC, I'm just going to write down, is 2, 6, and negative 3. So in essence, the length of AB has to be equal to the length of BC, okay? So I just kind of told you a second ago, the length of 1 is this squared plus this squared plus this squared, square root. So 9 plus 4 plus K plus 2 squared.
Foil.
We foil it.
Wait.
Okay.
What's the length? Oh, okay. You square them and you add them.
Right.
Okay.
That is going to be equal to,
You do like terms together?
we're going to, this is going to be equal to 4 plus 36 plus 9. Yes? Are we good? What do I know about 2 things that are equal to each other that are both under a square?
They're the same
You
thing.
square both sides, so that you can get rid of that square root, right? So I know on this side, if I clean her up a little bit, I've got 13 plus, you guys told me to square it. What's a mistake that'll be made out there?
Foil.
Forget to foil. That happens every day. K squared plus 4K plus 4 equals 49, right?
Square root of 49. Which
Well,
is,
I've got square roots, I got rid of both square roots on both sides.
oh, did
If
you?
If you're both equal to square root on both sides, you can square it and get rid of that. So, what does this scream?
I'm a trinomial.
I'm a trinomial factor me. It says I have a K squared, I got a 4K, and then I got 13 plus 4 is 17, and I'm going to subtract 49. Is that what it is? Negative 32?
13 plus 4 minus 9
Equals 0.
K minus 4, K plus 8.
4 is 8.
Is that what you're getting? K, K,
It's 4 and 8.
8,
Yeah, 4 and 8.
4, positive, negative. So K is negative 8, K is positive 4.
And that's the answer.
That's
The answer?
Uh-huh.
Oh, yeah.
That was an easy one, right? For it to be 4 points, that's crazy. I think the reason why it's 4 points, I know.
They made the other one tag. They made
I know.
Come on.
I think the reason why this was 4 points, though, is because you had to realize that you had to find AB first. Right?
Yes.
I agreed. If you understand the concept, it's like, that's breeze. But if somebody's not quite there, not so much a breeze. All right, so we got the 2 values of K.
And the magnitude of D.
All right. The point D is such that OD is the same direction as OA. Parallel. What does that mean to me?
That the ratio.
That their ratios are like, so if OA is 2, 1, negative 2, OD could be 4, 2, negative 4, right? So we know that it's a common, like, it's just a common ratio of it. Okay, so we're good there. So it's in the same direction and has a magnitude of 9 units. Yes?
Is magnitude length?
Yes.
Length. Right, right. So The square root of a squared plus b squared plus c squared is going to be 9 units. Okay.
For what?
The point D is such that OD is the same direction of OA and has a magnitude of 9 units.
So you find the magnitude
So-
of OA, and then you find the ratio.
Well,
Could you do that?
Yeah,
I don't know.
find D and E.
You do, but I'm just saying, like, to find the points of D.
well, the point E has is such that it's the same direction as OC and has a magnitude of
So
14.
you know magnitude and you know kind of the ratio.
So if I know, like, okay, let me write this out.
Oh, I
I've got
You just
OD.
find the length of
Its
OA.
length, right, of a squared plus b squared plus c squared is equal to 9, which means a squared plus b squared plus c squared is 81. If that makes sense?
Yeah.
Like, I don't want to worry about square
Right.
roots for a minute. So it's multiples of this that when I square it, I get 81. So, like, let's just play with the first one just for the fun of it. So, I know, okay, let me think out loud for a minute. When I square things and add them, I don't want to make it too big because it gets big really fast, if that makes sense. Like, let's do by 3, for instance. So if I said it's a multiple of 3 of this, it would be a 6, a 3, and a -6. Would you agree? So if I square them, what do I get? I get 36, 9, 36. What does that add up to?
81.
Does it really? It does.
Yeah, equals 81.
Well, that was just a guess. Okay, yeah.
So where does 6, 3, and -6 come from?
Okay, now it's telling me that OD is in the same direction as OA. So this could be a 4, a 2, a -4. This could be times 3, a 6, a 3, a -6.
Okay.
This could be an 8, a 4, a -8, and I just so happen to pick the right one. Yes.
But how did you know which one to pick?
I didn't.
Oh, so you just like guess?
I guessed.
Until you get it?
Right. Well, and remember, but listen, think about this. 81 is not that big. So if I did, let's just play for a minute. If I said, I'm randomly going to pick a 10, I would have 20, 10, and -20, which would mean 400, 100, 400. That's way too big. I know my numbers are going to be small. Reasonably. Yes.
Could you like algebraically solve it by, say,
I'm sure.
you had it, the a squared plus b squared plus c squared equals 81, right?
Yeah.
And then you plugged in for a, b, and c the numbers from OA, right? So you plugged in the 2, the 1, and the -2.
Right.
And in front of each of those numbers,
You put a
you
number.
put a constant, like say, x, right?
Yeah.
And then you went and solved, and you would get x,
And you would
because it
solve
would be
right.
the constant
You're
ratio,
right.
right?
Right.
So
Exactly.
that is how you do algebra?
Yes.
Okay, cool.
Could
That
you
makes
just do a totally simple way? You just find the length of OA and OC, and you find, and you get like 3 for it, and then you just find a difference. Simpler that way.
But
Okay.
it's different because you square it, and
I mean, they're parallel, which means they're multiples of each other.
does that always work?
Yeah.
That's weird.
Okay, I don't know why it always works, so that's cool. So OD is, and because we were smart and picked the right one at the right time, it was 6, 3, -6, right? What is OE? So OE is going to be in the same direction, and I'm just doing it my guess and check way, has 14 units. So what's 14 squared? 256 maybe? I'm wrong. 14 times 14.
196.
Oh, so close. 196. So a squared plus b squared plus c squared is 196. So you said if I plug in 2, 6, and -3 and put x's beside them.
X. So yeah, it would be
Oh.
2x, square that whole thing, plus 6x, square that whole thing, plus -3x, square that whole thing. Would it work? I think it would.
I don't know. You do it your way, I'll do it mine. So I know I have to get up to 196, a little bit bigger than 81. I used a 3 a minute ago. I'll try a 4, because it's not that much bigger, right? A little bit bigger, it might be 5. Okay, so if I'm looking at this, if I do 4, I've got 8, 48, am I right?
You're multiplying it by
I'm multiplying them by, right, times 4.
4.
Right. Yeah, I did that right. So, yeah, this is just a different number, so I was getting all confused. So I've got 8. Well, that's not even going to compare to the 3. Let me try the 3 again. So we got 6, 18, and times 3, 9, right? If I square them, that's too big, isn't it?
Try 2.
Yeah,
I think
it's 2. I did the algebra thing. The problem
I did it
is,
my way.
You did it your way.
I like that way.
I like your way too.
You just say 2x
So
plus 6.
16 plus 144 plus 36. And you get 196? Oh.
Yeah. Why is this? I don't understand.
Why does mine work?
No, why is it so much difficult than mine? I literally just do the final length OA,
Yeah.
and then you get either length is 9 and the square is 3,
Mm-hmm.
and then you do 9 divided by 3 is 3. And you do the OC, you find the length, and you have the magnitude, so you do 7. I got 14 minus 7, divided by 7 is 2. That's crazy. It's just simple.
Why does that work though?
Why wouldn't it work?
Well, because
It's the same ratio. It's a ratio. You automatically know they're parallel. It's the same ratio. It should work every time.
So what are you supposed to do
There's like 3 ways to do it now.
with this information?
Okay, now, what do we have? What do we do with this information? Let's see.
Subtract them.
Well, because it said now we have OE and we have OD. We found them. Find the magnitude of DE. So how do we find
Well, you have to
DE?
find
We do E minus D, right?
So it's the second one minus.
Always the second thing minus the first, right? So E minus D. So what is it? E minus D, right? And then you want to find it in the form of the square root. So they're looking for the magnitude of it. So I have to find DE, which we can do. 4 minus 6, negative 2. 12 minus 3 is 9. Negative 6 minus negative 6 is 0. Check my work.
What?
Square root of 85.
Negative 6 plus 6.
Right, yeah.
Square root of negative 85.
And so when you take the magnitude of it, you get 4 plus 81 plus 0, which is the square root of 85. And it wants the answer in the form of square root. Yes?
Okay, just one question. What do you want to find like a line that's parallel to a different line? Do you have to square like the individual numbers inside of the parentheses, or do you have
If
to
you're finding the length. If you're finding the length of it. All right, so that was a 10-point problem. Wouldn't it be something if you guys just kicked butt on the day of the test and you came out and you're like, I got 75 points, Miss Kay. I wouldn't know what to do with myself. I'd like pee my pants first and then.
How many points do you need to get your A level?
A level's about 81.
see.
Out of 125?
No.
Is this an A-level?
A level is 2 more tests.
No, like A. Get an A on
An A grade.
Oh, get an A grade. I thought you meant like A level next year. A grade was usually it's about the 80s, 70s, between 70s and 80s.
So
Yeah.
What is
Last year, 2 or 3 years ago, I had 3 kids get like 85 and earn A levels, and then we're good to go for the A level part. Yeah.
Wait, so you're saying if you do well enough on this test, you'll
You
get
have
credit.
to show up.
You'll get credit for A level as well.
No, you have to actually show up and take it.
No, like you'll get an A out
You get
of, on the
level
scale,
up
you would
and
get an A.
Right.
Right.
grade.
Your grade would be an A. Then you went to sit next year for a test. You have lots of points that'll pull forward.
Oh, so they use what you get this year?
Yeah.
next year?
Yeah.
Okay.
So I had kids that earned the first test, like you guys are going to take an 80 something,
Like
right? And then they pulled those into the next year. So they were like sitting pretty.
When do you find out how many points we actually get?
August. Yes.
Okay, so the 40 points, that's to score a C on the test.
To score an E.
Okay, that's what I thought. I was like, I'm getting confused with all of
E
the...
gets it.
You get
Listen, at this point, I'm just happy if y'all pass. Okay, last but not least, ready? Yes, Ian. Yeah. The function f is defined by f of x. Okay, once again, my kids saw what?
Sine.
And they cried, and they walked away. And so here they also saw negative pi over 2 to pi over 2. Honestly, don't get scared about that.
It just means radian.
What does that mean? Negative pi over 2 is negative 90 to 90.
Yes.
So it's here to here. So literally it's going to be 0 to 90 or 0 to negative 90.
Yeah.
Okay? So we have f of x is equal to that, and then it wants me to state the range of f.
So
all the outcomes.
So, like the values that can potentially happen. Like, so your range depends on your domain. Does that make sense? So everything that it could potentially plug in, bless you, everything that it can potentially plug in into that for x,
yeah.
the outcomes are my ranges. So I'm going to start with the minimal, negative pi over 2, and I'm going to work my way up to pi over 2.
Really?
That's what I'm going to think about. And what's happily in the middle? Happily in the middle is 0. So I'm going to look at those three things and see what happens. So at negative pi over 2, which means, go ahead.
So you don't have to put like all of those numbers.
No, because we're going to do a range. We're going to show it as a range.
There's infinite numbers.
The range for a range. So at negative pi over 2 is down here.
Yes.
What happens when I plug in negative pi over 2 in there? So what is the sign at negative pi over 2? Sign is the y value, so negative 1. Right? So if I'm plugging in this, I got 4 times negative 1 minus 1. I got negative 4 minus 1, negative 5. Agreed? Does that make sense?
Yeah.
Okay, what happens when I plug in the centrally located one, the 0?
It's negative 1. It's negative 1.
Okay, so I'm going to plug in 4 times 0 minus 1, I get negative 1.
And
Okay.
then 3.
And then I'm going to plug in the positive one, right? So I've got 4 pi over 2 is 4 times 1 minus 1, which is 3. Just for the, you know what, and giggles, I'm going to pick a point that kind of falls like in between here that might work for me. Something that's easy to work with. For example, 30 degrees. Okay, that falls in this range. If I pick 30 degrees, the sign is 1/2. That's kind of easy to look at. What is 4 times 1/2? 2. 2 minus 1? 1. So right here, does it make sense that the y value is 1? Does it make sense that the y value is not going to get any bigger? How about like back here, if I plug in the negative 1/2, I would have 4 times negative 1/2, I'd have negative 2 minus 1, negative 3. Does it make sense that it kind of falls where it's supposed to? So what's the range of this?
Negative 5 to 3.
Negative 5 is less than or equal to y is less than or equal to 3.
It's 1 to 3.
Because it's range, yes.
So it's not equal or the y.
X, cosine is x,
Okay.
sine is y, x before c, x before y, c before s. You with me? Okay, we'll have to finish it tomorrow.